Well, a very quick lesson here on finding coefficients. We call these A, B, C, D problems. I mean, they don't. It doesn't have to be the letters A, B, C, D. But what we're talking about is we're looking for constant coefficients. So I mentioned that in the example here. A function ax cubed plus bx squared plus cx plus 30 has unknown constant coefficients a, b, and c. When we see letters like a, b, and c, those are most often used in math and science as constant coefficients. So this a, b, and c we're looking for on the question, the a, b, and c's are like 2s or 7s or 4.9s or 3/2 or something like that, some constant number. So we're looking for the coefficients of this polynomial. And these kind of questions actually have popped up all the way through high school math. But the ones today are just a little bit more complicated because they involve derivatives. So I thought I'd do one good example that you have to look at as you go to look at those problems. Okay, so there's a function, y equals ax cubed plus bx squared plus cx plus 30. And has these unknown coefficients a, b, and c. The function has a minimum at x equals 4, goes through the point negative 2, 18. Also, it is known that the slope of the tangent when x equals 0 has value negative 8. Find a, b, and c. At first glance, when you haven't seen a problem like this before, it may seem totally impossible that we can get all this information. So these are, you have to have faith. You have to believe that there's enough information here to work with and just slowly work your way towards the answer. Well, I'm going to write down the function here, y equals ax cubed plus bx squared plus cx plus 30. And they mention the function has a minimum, and they mention the slope of the tangent. So this sort of implies to me that I'm going to have to use the derivative at some point. So I'm going to go ahead and find the derivative right over here. Y prime equals 3ax squared plus 2bx plus c. The derivative of ax cubed, to bring down the 3 and multiply it by the a. So that's 3a, reduce the power by 1. Do the same thing for bx squared, bring down the 2, multiply it by the b, so I get 2bx. And then derivative of cx is just c, derivative of 30 is 0. And so now I've got some equations to work with. Now I go back and look at the question and see what information I have and how it can be used. And actually, I started drawing a line here, and I'm going to continue drawing a line because every single piece of information I'm going to have this decision to make. Am I using the y equation or am I using the y prime equation? Am I talking about y values or am I talking about derivatives? And I'm just going to go in order. When you get more experience at them, you might go through and cherry pick the information that it will produce the most fruit. But I'm just going to read them in order when I do it to go through here. The function has a minimum at x equals 4. Well, if it has a minimum at x equals 4, I can go over here to the derivative and say, when x equals 4, the y prime will be 0. That's what I do know about at a minimum, is that the derivative is going to be 0. And I just sub those values in. That is, y prime is 0. Sub in x of 4. And after I tally that up, I get 48a plus 8b plus c. And that is frustrating. If you haven't seen these problems before, you look and go, well, that didn't really get me anywhere. But you notice what I've done. I've drawn a box around that equation. I'm like, oh, this is a good equation. It's got a's, b's, and c's in it. That's more unknowns than I want, but it is information. I move forward with information. So part of these type of ABC problems is having some patience and going, hey, this is production here. Things are moving forward. Let me move on to another piece of information and see what else I can find out. So the next piece of information is, it goes through the point negative 2, 18. Well, that's over here. That's a point. That's not the derivative. So I'm working with the y values there. And so what I find out there is when x equals negative 2, y equals 18. So I can sub that into this equation on the left-hand side here. It's the y equation. It didn't talk about slopes. It talked about a point. So I go 18 equals a times negative 2 cubed plus b times negative 2 squared plus c times negative 2 plus 30. Just enough space there. And then I'm going to tidy that up. I get 18 negative 8a plus 4b minus 2c plus 30. Well, maybe I'll move the 30 over with the 18 just to tidy that up a little bit. I get negative 12 equals negative 8a plus 4b minus 2c. Again, very, very frustrating if you haven't seen one of these before, because you're like, well, that didn't help either. all I've got is a big messes of A's, B's, and C's. How can I possibly get all this stuff? And you have to be patient with these type of questions and just keep subbing in information until something cracks loose. The last piece of information says also it is known the slope of the tangent when x equals 0 has value -8. So that's slope of tangent, so it's on the y prime side of things. When x equals 0, y equals -8. And I said something earlier that might have frustrated you a little bit. It said, well, maybe you can cherry pick this information and get through this question a little bit faster. Or I sort of implied maybe it could be done a little faster if you knew what to cherry pick. And that's frustrating when I say things like that. You're like, oh, well, why don't you just tell me what I need to know? Well, here I am going to tell you now. Subbing in x equals 0 bears fruit very quickly, and I'm going to show you why right here. So if you were going to do another one of these questions later, you might scan through and look, hey, is there some way I can sub in x equals 0? Because that's really going to get me some results, and I can be a little less patient when I do that. You don't have to, but that's just my little hint in these. So if I go to this y prime equation, oh, I made a mistake there. When x equals 0, y prime equals -8. I got too busy talking about my x equals 0 there. Okay, so y prime is -8, so I go -8 equals 3a times 0 squared plus 2b times 0 plus c. And can you see now why subbing in an x value of 0 immediately bears fruit? All the terms with x's just disappear, and I get some great information. C is -8, and for the first time, I'm pretty happy about what's going on in this question because I found out C is -8. That is, I can take that C and I can put it in here, what I will call equation 2, because it's just over on the right-hand side. There's no reason to call it equation 2 except it was on the right-hand side. And I'm going to put it in here, what I'm going to call equation 1, and I'm going to say, okay, sub in C equals -8 into 1 and 2. And I'm using these 1 and 2 in circles on purpose because you might remember from grade 10 when you did substitution and elimination, this is the way we labeled these equations. And so that's going to help maybe trigger our brain into what's going to happen at the end here. I've already given it away here, but so into 1, I go -12 equals -8a plus 4b minus 2 times -8. So I get -12 equals -8a plus 4b plus 16. I'm going to bring that 16 over, and I get -28 equals -8a plus 4b. And I'm going to call that equation 3, because I'm really happy about equation 3, because it's got only a's and b's. When I sub that c equals -8 into equation 2, I get 0 equals 48a plus 8b minus 8. And I'm going to bring that 8 over. 8 equals 48a plus 8b. And I'm going to call that equation 4. And I'm very happy about that equation as well because it's only 2 unknowns. We started out with a's, b's, and c's. Now I've got 2 equations with just a's and b's, which makes me very, very happy. And I'm going to write them over top of each other to really try to trigger your brain from grade 10 academic. -28 equals -8a plus 4b. I guess technically I should be going, this is equation 3. This is equation 4. And there's multiple ways to solve this now that I'm down to 2 equations and 2 unknowns. Either substitution or elimination. Those things are going to come back now, all the way from grade 10. A quick lesson on substitution and elimination. If you want to use elimination, what you want to do is match up one of these variables. And I'm going to look at the b's. You could do the a's just as easily. I'm going to take equation 3, and I'm going to multiply it by -2. I can multiply equations by anything I want, as long as I multiply both sides by the same thing. So I get 56 equals 16a minus 8b, and I'm not going to do anything to equation 4. Oops, I didn't mean to draw a line there. I really don't want a line there. There we go. And then equation 4, I'm not going to do anything with again. And if you didn't know what I meant by line up the terms. That's what I meant when I multiplied that by -2. You see, I've lined up -8b with +8b, allowing me to add the equations. I like adding equations. I make less mistakes when I add equations instead of subtract. You could have lined them up and made b's the same coefficients, but both positive. That would have worked as well. But I decided that making one positive and one negative by multiplying by a negative makes things line up better. And you'll see what I mean. Now I can just add the equations. This is the elimination part of elimination. And when I add those equations, I get 64 equals 64a. And the -8b and the 8b cancel each other out. That's why it's called elimination. I've eliminated the b's, and that allows me to solve for a. And a is a pretty simple number here. Often these ABC questions, we keep the a's, b's, and c's simple when you're first doing these. And then to get the b, I sub a equals 1 into, well, I'll have several choices. I think the easiest one to sub back into will be equation 4, but it'll work in equation 3. It doesn't really matter what one you put it into. And so I get 8 equals 48 times 1 plus 8b. And I'm almost home here. Oops. I don't know why I wrote an equal sign in the middle there. And then 8 minus 48 equals 8b. -40 equals 8b. Divide by 8. And I get b equals -5. Therefore, a equals 1, b equals -5, c equals -8. So that's the basic process of those. Sub all the information they give you into the equations for y and for y prime, and soon maybe some y double prime. But even subbing into y double prime isn't any harder, actually, because it'll have less variables probably. You'll see when you do them. And then use that to algebraically reduce things down, and maybe some substitution or elimination in the end, depending on how difficult the question is. Some don't have substitution or elimination at the end, and some do. I did elimination here. It wasn't a great choice of a question to do substitution. When would you do substitution? If those coefficients, instead of 8a and 4b, maybe it was just b equals, like 8a plus b. If the b is by itself, then substitution can be a little better. Okay, a few practice problems there just to get warmed up for those. You might have seen problems like these before in other homework, but in this chapter, we're going to need that flowing through the chapter every once in a while. So we take one section and dedicate our time to it to make sure we have it down pat. All right, knock down that homework and have a great day.